Welcome back. In this lecture, we're going to talk about template functions. Let's go back to our Visual Studio project. Now, sometimes we might want a function that not only can take inputs as parameters, but can also take a type as an input. This makes functions much more flexible. This is how we make a template function. We first use the word template, and in angle brackets, we specify a special type of input parameter using type name, followed by the name of the parameter. Now with templates, you'll usually see t as the input parameter name, but it could really be anything. T is just more of a tradition. Now we declare a function. So for example, I might have a function that returns t called avg, short for average, which can take a t as input called first and a t as input called second. Now let me explain what this means here. Whenever we call average, we have to specify the type for t. So we may call average specifying float for t, in which case we'd be passing in floats for first and second. But we could really pass in any type we want, as t is a type parameter. This will make more sense with an example. Let's go ahead and create a function definition for average. And here is our function definition. Notice that Visual Studio added this template type name t line. It has to be there for the function definition as well. Now notice that Visual Studio simply provided us with a function definition here in the .h file and made it inline by default. Now inline just means that this function, wherever we call it, that function call will be replaced by the function body here at compile time, just like a macro would. Now we can perform some sort of action on our input parameters, such as taking their average. So I can place parentheses here and add first plus second, and then divide this quantity by 2. And whatever values that we pass in for first and second, we have to specify what their type is. So first and second could be floats, they could be doubles, they could even be f vectors. And the reason this would work for f vectors is because the f vector type supports addition with the addition operator, as well as division with the division operator. If we passed in a pair of f vectors, we would add them together here using component-wise addition. That's what the addition operator does with two vectors. And division will perform component-wise division on that result, dividing x, y, and z each by 2. So this would effectively give us the average between two f vectors if that's what we passed in. So this function is really pretty versatile. It can take in any type for t, provided that that type supports addition and division with these operators. So that's an important caveat. So let's see how this template function works. We can go back to item.cpp and go into begin play, and we can call average. And in order to call average, because it's a template function, we have to specify the type that we're using for t. So we could use int32, for example. And we then have our parentheses where we pass in the actual inputs for first and second. So we could pass in, say, 1 and 3, and average will perform its function body on this. Namely, it'll add 1 plus 3, then divide by 2. So this should return an integer of 2. And if we hover over average, now that we've specified int32 for that template type, we now have a new version of average that takes int32s. We can prove this with a UE log. So we can say UE log, log temp, warning, text, and we can format this string by saying average of 1 and 3 with %d, as %d is the format specifier for integers. Think of it as taking a discrete value. And if we're going to have %d, we need to specify the integer, and that's going to be what we return from average. So let's just create a local int32 here called average int. And we'll pass that into UE log, so average int. So saving this, we should have this printed to the output log twice, as both of our BP items in the world will have their begin play functions called. So hopping back into the editor, let's open our output log, and we'll go ahead and hot reload first. And after hot reloading, we can hit play. And now we see average of 1 and 3, and the answer is 2. So the function worked by specifying an int32 as the template type parameter. But because this is a template function, we could specify other types as well. Let's make a float called average float, and we'll call average, but this time in our angle brackets, we'll specify float as the template type. And now we can pass in two floats, such as 3.45f and 7.86f. And average should provide us with the average between these two. So let's copy our UE log line and paste it just beneath this line, and we'll say average of 3.45 and 7.86. And instead of %d, we'll use %f because we're now going to pass average float into UE log. So let's save this, and we'll hot reload in the editor, and we'll go ahead and hit play. And now we see the average of 3.45 and 7.86. It's 5.65. So our function works for integers and for floats. But the cool thing is, we could use an f vector too. So I'd like to do something interesting here. I'm going to go ahead and remove these lines from begin play. And I'm going to go into our tick function. And let's make use of our average function with f vectors. So we can make an f vector here, and we'll call this average vector. And we'll use the average function specifying f vector as the type. And now we can pass in two f vector values. The first one I'll pass in is getActorLocation. And the second one I'll pass in is an f vector with 0 for x, y, and z. Now we can access the f vector's static variable called 0vector. Now 0vector is a vector that belongs to the f vector struct, but it's a static variable, so we can access it without actually having an f vector existing, so we can access it from the class itself without needing to get it from an actual instance of an f vector. So average is now going to be the average between these two vectors. And when you take the average between two vectors, you're left with the vector, which is the midpoint between these two. So we can show this with a debug point. Let's use our macro draw point single frame. And this requires a location. We're going to use our average vector. So let's save this, and we'll go ahead and hot reload, and let's hit play. So check it out. These points are showing us the midpoint between the origin and the actors themselves. So if we go ahead and take one of these actors and move it out and away and up, then when we press play, we'll see that the midpoint has moved as well because it's exactly between the origin and the actor itself. So we see that our template function actually worked with f vector as the type parameter. So template functions are extremely versatile because they allow us to have one single function that does the same thing on its input parameters regardless of the input parameter type. Now, again, I mentioned that the type has to support addition and division, and some types don't support that. For example, we can call average passing in two f rotators. Let's make an f rotator and call this average rotator. And we'll initialize it using the average function specifying f rotator. Now, an f rotator is kind of like a vector, as you know, but it has yaw, pitch, and roll. Well, what happens if we pass in two f rotator values, such as getActorRotation and f rotator, 0 rotator? 0 rotator is simply a rotator with yaw, pitch, and roll equal to 0. Well, if we save this and we go back and try to hot reload, we see that our build failed. Now, why is that? Well, right here, this error message says binary slash or division, no operator found which takes a left-hand operand of type UE math T rotator double. So that's an internal type used by the f rotator. and it says, or there is no acceptable conversion. So it would have tried to convert implicitly if it could, but it couldn't. See, there is no division operator for rotators. It's just not defined for rotators. It wouldn't make sense to try to divide one rotator by another. To do that, you'd have to specify your own custom functionality, and that's not built into the engine. So this is an example of one limitation of template functions. The type that we pass in has to support everything we're trying to do in that function. And in our function, division is not supported for frotator. So that's another caveat to be aware of when creating template functions. But as long as you don't misuse the function and you only use it using types that you know are compatible with the function, it can be extremely useful. So now that we understand template functions, then we shouldn't be caught off guard in the sections to come where we're going to make use of some of the built-in functions in Unreal Engine, which happen to be template functions. Excellent job. I'll see you soon.